Hi students, I am your geography teacher. So today we are going to discuss another topic that is very interesting. In previous video, perhaps you know, I discussed already the one theory regarding the origin of the universe, that is the gaseous hypothesis by Kant. So today I am going to discuss the another topic, the next topic, which is developed on the basis of the Newtonian law and on the basis of the Kant. Okay. So in this video we are going to discuss the nebular hypothesis of Laplace. Okay. Previously, in previous video we discussed already the one theory that is too much important, that is the first scientific theory about the origin of the universe, that is the, you can say, the gaseous theory. But in this video we are going to one step further and we will discuss about the nebular theory. In previous video we already discussed the some criticism or the erroneous concept of the Kant hypothesis. There we discussed that the somewhere the from where does the nebula come, that was, you can see, the unexplainable to the Kant. Okay. So in this video so that is why the main thing was that, and we also discussed that the how the motion came into the gaseous or the nebula, that was unknown, and collision, if there is a collision, so collision always, if two particles collision each other and creates a circular motion, that was also impossible in the theory of the Kant. And also the fourth criticism we already discussed, that there will be the, you can say, the vast ratio or the, you can see, the angular momentum, that angular velocity which is inverse to the radius, means its radius is radius will be high, so there will be the, you can say, the speed also, angular momentum also be high. So this concept was against of Newtonian law. So that was the concept, means where the all the drawbacks, all the, you can see, the lacks or the, you can see, the loopholes in the theory of the by Kant, that was solved by the one of the scientists at that time, you can say, that is the Laplace. Okay. And he somehow he wrote this hypothesis, you can say, that is the 1789 and published in 1796, and he wrote also a book. This Laplace wrote one book, the book name is the Exposition of the World System. Okay. And in this, where the Kant did some mistakes, 1 2 4 1 2 3 4 4 criticism, he tried to, you can say, the solve the all the answers, and his you can say the his concept or also that is called the hypothesis. Okay. And hypothesis always, you can, perhaps you know, that is based on the assumption. Okay. So assumption, first assumption he took in the in the hypothesis of the Kant, he discussed that the nebula was very cold. Okay, first thing he discussed. Second thing, he assumed, the Kant assumed that that was the motionless. Okay, that was the motionless. But first thing, what to about these two assumption, first you can say the Laplace assumed that he assumed that there was a, you can see, the hot and you can see the hot, that is the high velocity nebula. Okay. He discussed this thing again and again. So first two criticism which was arised during time of the in the hypothesis of the Kant, that was fully, you can say, the abolished this time. Okay. So these two concept, you can say, the, because he Laplace taken, that is there was a hot nebula. Okay. Hot nebula, and that was, you can see, the that was the moving. So that is the main thing, and that was the hot nebula. Okay. So this thing, then the hot nebula also creates some, you can say, what, that the motion. Okay. And that was also motion, in motion, this hot nebula in motion, means speed was there. So first two criticism was abolished by the Laplace. Second, the third thing, what this he actually discussed, collision creates the circulatory motion, that was also criticism and in the theory of the Kant, that was also abolished by this. Means he considered that when there is a, you can say, there is a hot body or the hot nebula, so what happened, this warm nebula, you can say the emitting the, you can see the temperature. Okay, if it's emitting the temperature, so what would happen, so that time this will be construct, means the, if there is a high temperature, so that time the particles of the anything that will be the spread out. Okay, if you take example of the ice sheet or ice, so that time if the temperature, so that converted into what, water, and water, that will be the, so that's the main thing. And again, so this thing applied in this, that when there is nebula is very hot, is started to emit all the heats to the, you can say, the universe. So what happen, if there is a emitting the temperature, so that become the construct, means the size of nebula that time decreased. Okay, so if the size is decreased, so that time the angular velocity, means that was also increased, because on the basis of this theory we already discussed that angular movement, that is the inverse relation with the r square. So if this this mass is reduced, so that time what would happen, this mass is reduced due to this fact, what happened, the radius is reduced, with the mass is reduced, due to this fact what happened, the angular momentum, means angular velocity, that was also what, that will increase. So this thing actually happen in this. So this in this way Kant also tried to Laplace also try to explain this thing. So fourth criticism which was arised during time of the Kant, that was also abolished by this theory. Okay, so first thing is that. Second, if you want to, so what happened in this case, what happened, what he actually explained at the on the basis of this theory, what is the theory of the Laplace, which was published in the 1796. Okay, 1796, this theory or the hypothesis was published. Okay, in this hypothesis what he actually, he already assumed that there is a hot nebula. Okay, there is a hot nebula, but you can say that hot nebula, you can say that was the expand and the heat goes to the outside. So it started to expand, so heat go to the outside. So this is the second step. Third step, when this heat go to the outside, so what happened, this started to contract, means the size of the nebula that was decreased from this size to that size. So what happened, so when this is started construct, you can say the, so speed of this, means the angular momentum, or you can say the angular velocity, that was the w was increased. Okay, w was increased, means the angular velocity, previous slide we already discussed. So what happened, started to move again and again, and the speed was increased. So if speed increased, so sometime what happened, one of the, you can say the, one of the piece or one of the, only one ring, you can see the comes out from the wire, from this one. Okay, from one ring comes out from the nebula, and this nebula, what happened, one ring when comes out. So in the case of the Kant, he said there is a 9, okay, 9 rings comes out from the nebula, but in the case of the, in the hypothesis of the Laplace, he considered or he assumed that the one ring comes out, and from one rings 9 planets, actually 9 rings again divided into 9 rings, or the 9 planets. So this is all about the theory of the, you can say the what, Laplace. Okay, so this is the theory of the Laplace. Actually this is a similar theory to the Kant also, you can say that this is the similar theory of by whatever explained by the Kant, but there is a difference where the whatever the criticism first came in the hypothesis of the Kant, Laplace first tried to abolish this you can see the criticism. First criticism, Kant discussed that there is a hot nebula, okay, there is a hot, you can say the cold nebula, and that the motionless, but Laplace said that is the hot and that was in motion. Okay, speed was there. So one by one he discussed. So slowly if we review this thing, so there is a hot nebula according to the Laplace, and hot nebula, you can say the what, expand, and the hot goes to outside the, and it start to construct and increase the circular momentum. Momentum means the movement started, and due to this fact what happened, one ring you can see the come out from the nebula, and this nebula you can say that divided one ring from one ring, this divided into 9 rings. Okay, 9 rings of the 9 planets. So this is the all about the, you can say, the Laplace hypothesis. But this theory also you can say the not out of the criticism. This is also come under the criticism. Number of question arised. Okay, number of question arised during this, or when he published this hypothesis. First actually, just a minute. Okay, first what you can say, just okay, first criticism, the origin of the nebula hot and circular motion, but where, from where, according to this is the theory of the Laplace, or the hypothesis of the Laplace. So okay, so Laplace first he described there is a hot and motion. First thing he described what, there is a hot and motion. Okay, what, the motion, you can say the what, motion, you can see the nebula. Okay, so what happened, so from where this has come, so in this case the current was also unable. In the case of the, you can see the cold and motionless nebula, and in the same time you can say the Laplace also unable to explain about the what, the hot and motion nebula where come. So that was the, and again he discussed that is the 9 planets. Why there should be always 9 planets? Because today we can see the 9 planets, that's why they assume that the 9 planets or the 9 rings comes out from the nebula. So again this question was also unexplainable in the case of the Laplace, to the Laplace. Okay, planets and the gaseous, you can say the planets, if there is a planet, so all the nebula whatever we consider, that was the gaseous in form. Okay, so nebula always gaseous is form. If gaseous is form, so after the gaseous there should be, if there is a construct or the temperature decrease, so that time that converted into what, the liquid, as we can see the in the case of the ice. Okay, ice first solid, then the liquid is the water, and there is a, if there is a heated up, there is a vapor. Okay, so if you consider, so there that should be, there is a liquid form. Okay, so if there is a liquid, so how this liquid move around the sun? Okay, so rest of the, so we already discussed about this, the rest of the portion of the nebula that converted into sun, and the rest of and 9 planets. Okay, so this was also unexplainable to the, you can say the Laplace. Means why this, means the planet, if planet there is a gaseous form, there should be liquid, so liquid after the solid, but how this liquid form of the, you can see the planet, that can move around, or the there is a motion. So that is the, that thing we have to understand, that is also understandable. Second thing he discussed, actually L is equal to m W square, means the that we already discussed already in the previous theory we already discussed, that is the L is equal to, means the angular momentum, mass, this is the mass, this is the, you can say the angular velocity, and this is the square of the radius. But in the case of, if you see that the, if there is a more mass, so there will be the more mass, so more mass creates the more, you can see the what, more mass, that can create the more, you can see the velocity. Okay, so but in the case of the, you can see the 2 planets, you can see the sun, sun and the 9 planets, if you discuss the 9 planets, sun have, you can see the sun have this much of the, you can see the mass in tons if you want to discuss. So 99.9% mass have sun, but the motion is only 2%. On the other hand, that the, you can say the planets have the 0.1% of motion, 0.1% of motion, but what happened, 0.1% there is a mass on the planets, but 98% okay, they have the motion. So more mass and more angular momentum, so that is also wrong, okay, that also proved as a wrong. More mass, but it is not true in the case of the sun and the 9 planets, because sun has the most of the mass but have the only of the 2% of the motion, means very motion, you can see the speed is of the velocity is very low, but 9 planets which have the only 0.1% of the mass total our solar system, but these have a 98% of the what, 98% of the you can see the angular momentum. Okay, so this is the all about the Laplace theory. Okay, again we will come the another video regarding, you can say, the planetesimal hypothesis, that was the discussed by the Chamberlain and the Moulton. Okay, so till then, bye all of you.